Back, Advent of Code 2016, day 18, like a rogue. As you enter this room, you hear a loud click. Some of the tiles in the floor here seem to be pressure plates for traps, and the trap you just triggered has run out of whatever it tried to do to you. You doubt you'll be so lucky next time. Upon closer examination, the traps and safe tiles in this room seem to follow a pattern. The tiles are arranged into rows that are all the same width. You take note of the safe tiles dot and the traps hat in the first row, your puzzle input. The type of tile, trapped or safe in each row is based on the types of the tiles in the same position and to either side of that position in the previous row. If either side is off center, it counts as safe because there isn't a trap embedded in the wall. For example, suppose you know the first row with tiles marked by letters, and you want to determine the next row with tiles marked by numbers, A, B, C, D, E, 1, 2, 3, 4, 5. The type of tile 2 based on the types of tiles A, B, and C. The type of tile 5 is based on tiles D, E, yeah, and an imaginary safe tile. Let's call these three tiles from the previous row left, center, and right tiles, respectively. Then a new tile is a trap only in one of the following situations. Its center and its left and center tiles are traps, but the right is not. Center and right tiles are traps, but the left is not. Only the left, only the right tile is a trap. In any other situation, the tile is safe. Then starting with row, dot, dot, hat, hat, dot, you can determine the next row by applying those rules to each new tile. The leftmost character on the next row considers the left non-existent. So we assume safe center, the first dot here, and then safe, and the right is safe, tiles in the previous row. Because all of the trap rules require a trap in at least one of the previous three tiles. The first tile in the new row is also safe. So dot. Second character in the next row considers left, center, and right tiles from the previous row. This matches the fourth rule, only the right tile is a trap, therefore the next tile in this new row is a trap. Third character considers dot hat hat, which matches the second rule, therefore is a trap. The last two characters in the new row match the first and third rules, so they're also traps. So then we have the next row, like this. Continuing, we get this as a third row. Then there's a larger example. So in this larger example, there's 38 safe tiles, starting with the map on your puzzle input in a total of 40 rows. Okay. How many safe tiles are there? So we have this input, or we can do test. Maybe this one. So the first thing I noticed is looking at the rules. Left and center are traps, but the right is not. Then it's a trap. And if the left is left tile is a trap, the center is not, but the right is not, then it's a trap. So basically we can ignore the center tile. We can just check left and right. If they're different, one is a trap, one isn't, then we have a trap. Because in the other situations, the tile is safe. So we can just go through each character. can make a new row map. Let's do this. Maybe we can make it padded first. Well, actually, we don't really need it. We can just check indexed. When we're at the first one, we know that the above, put the solution here. Here we know that the above is safe. It's kind of like this. So this is safe, this is safe, this is safe, so this is safe. Hmm. We can do it like this. L equals 0, it's a dot, else it's always end up using when if it's like this, it's a dot. We can also be the last index. Doesn't matter actually. Else test. Then R is similar if I equals test last index. Otherwise +1. So it goes one further. Then center we said we can ignore. L is a hat and if L and R are hat like here, then we go dot again. Save again. Need this. So if L is a hat and R is a dot, or L is a dot and R is a hat, then we have a trap. This, else, dot. Then we can do this. Registry. Then we print next and see what it is. Okay, so that's what we expected. Let's check this one. This, okay. We can do the bigger example and see what happens if we do it 10 times. Get next. That's interesting. Look at this. I got one too many. No. 'Oh yeah. This is not the same. So we could get some kind of function that dots or traps. Save tiles. Dots. Then we can count it. That. 38. And we already have the puzzle input, so we can just do this. We have 488. That's not correct. Well, I probably have to repeat it more. Forty times. 2013. Interesting. Clean this up. Okay. And then we want to check 40,000 rows. And that's it for day 18. So what do? We have a string for 40,000 times. We want to take the input string and make a new one that has a replacement for the traps. If the left, we check the left tile from above. If it's the first one, then it's the left from one from above will count as safe. Otherwise, we check if it's a dot or a hat, so trap based on the left one from the previous row. Then we do the same for the right. If it's the last index, it's safe. But if it's not, then we check the right one from the previous row. So if the left one is a hat and the right one is a dot, or the left one is a dot and the right one is a hat, then we have a trap, otherwise we're safe. And we do that for every index in the string, making the new string by joining again. Then we can count the safe tile, so the dots, and do the total sum, and then the end of the result.